Hey everyone, we're going to find information about the parent function, the absolute value function, and basically this is all the information we're going to find. If you want to write this down, write it down, because what I tend to do is put all the information on one page. What we're going to do for F and G is just find where y is positive and where y is negative. And the difference between that and this one, we're just going to discuss the end behavior of the function. And this symmetry here I'm going to discuss. Let me put that in yellow. The symmetry is going to go with the even and odd. I'll discuss those at the same time. Okay, so basically you have this written down. This one's very much similar to the quadratic function we did. So if I do a table of values here, I'm going to go ahead and do it on this side here. I'm just going to pick some domain values. And you know the absolute value. So for example, absolute value of -2 equals 2, and the absolute value of 2 equals 2. So basically it's just going to go to 2, 1, 0, 1, 2. Alright, so let's look at it. I went ahead and graphed it, and we did the table of values. The domain, I'll go ahead and put it up here, is all real numbers, because x can be any numbers. We can keep plugging in x, so x is all real numbers. And then the range, just like the quadratic, it will never be negative, because if you look at this here, this will never be negative, because when you take the absolute value, it's positive. So the range is y is greater than or equal to 0. Are there any zeros? Yes, right here, that's your x-intercepts. There's only one, and it's at 0, 0. All right. It's also a y-intercept. They want to know where is y positive. Y is positive in this case, in quadrant 1 and quadrant 2. It is not negative, because we don't have a negative here. All right, let's discuss the end behavior. And what we're talking about is we're looking at this end stuff here. So we're looking this way on the x, and then this way on the x. So what we're going to say on the end behavior is my y is getting bigger and bigger. So my x approaches infinity for this one. We're doing this one right here. As x goes to infinity. Okay, on this side, we're going to say this y keeps going to infinity here. So my y goes to infinity as x goes to negative infinity. And why did I write x again? Okay, so it goes to infinity as x approaches negative infinity. Remember, that just means as x gets larger and larger negative values. All right? The symmetry is symmetric to the y-axis. That means it's symmetric to the y-axis. That means it's an even function. All right? Also, it's not one-to-one. Okay, it's not one-to-one because when you do a horizontal line test, it hits at 2 places. That's important because when we do the inverse, if the function's not one-to-one, that means we have to restrict the domain. And the way we're going to restrict the domain is we're going to restrict it to the quadrant 1. So we're going to restrict the domain to x is greater than or equal to 0. And I'll go over here and graph that. I'm just going to restrict it here. And I know it's just like a linear line there. All right. So when I restrict the domain to x is greater than or equal to 0, you can put some points in here. Remember, this is y equals absolute value of x. So that goes 1, 2, and 3. When I switch the x and the y, basically they're the same. So if I just switch the x and the y here and make this the y and this the x and I plot it, what happens is you get the graph. So it lies on top of one another. Okay, so that's the inverse function. And that's given the restriction. And again, if we didn't give the restriction, I'm going to show you what would happen, and then I'm going to erase it. If I didn't do the restriction, what would happen is you would get also this side. I'm just going to, and that would mean that it's not a function because it doesn't pass the vertical line test. So basically, that's why you have to restrict the function if the function is not one-to-one. Okay, we have to give the general form for the transformation, which is going to be y equals absolute value of x minus h plus k. So I'm going to go ahead and draw just the parent function again. It's just like linear, but on both sides. Okay, here we go. All right, and I'm going to go ahead and first thing I'm going to do, we only have to give 2 transformations, so the easiest ones to see are the horizontal and vertical shift. So all I'm going to do here is on the key points, move everything over by 2. And basically, it's pretty easy, and you just kind of draw it. It's really hard to draw on this iPad, so basically I'm shifting everything over by 2. So that's something like that. And then I'm going to do the horizontal, that's the horizontal shift. Whoops, let me do that in green. So that's the horizontal shift. That was to the right by 2 units. And I'll do the vertical shift. I'm going to shift, let's see. I'm going to go ahead and shift it up by 3. So I'm just going to shift everything up by 3. That's the vertical shift up by 3. And so I'm just going to go up 3 here. And then just kind of graph it as if this was my new origin. And again, it's kind of hard to draw in here, but I just shifted everything up by 3. And that's how you would do the transformations. And that is all. Thank you. I think the next one I'll do is the cubic function. Thank you and have a nice day. Bye-bye.